What is an experimental design? What are design of experiments, aka DOEs? What is multivariate testing, aka MVT? I'll answer all of these questions because actually they're the same question because they're pretty much the same thing. Not exactly, but they're pretty much the same thing. So imagine you are baking cookies and you want to bake the perfect cookie because who doesn't? I mean, we're talking about a perfect cookie here, but how much flour and sugar? And what type of chocolate chips? And at what temperature and for how long should you bake it? And how do you figure out the perfect combinations of all of those things? Well, that's where a DOE comes in. See, using a DOE is basically saying, hey, let's try lots of different combinations of stuff and see what works best. But we don't want to just haphazardly throw ingredients together and hope for the best. We want to be systematic about it, right? We want to have some forethought, plan it out, and make it such that we can analyze properly when we're done. Now, each of those things that we can change, the flour, the sugar, the baking, etc., we call those things factors. And let's just start with 2 factors as a straightforward, easy example. Oven temperature and baking time. So for temperature, we can have lower temp and higher temp, keeping it simple. For time, we can have short time and longer time. Now, there are all sorts of designs for experiments, but the most basic DOE is called a full factorial. And it's called that because you try the full set of combinations of the factors, right? Full set of factors, full factorial. In this case, with the oven temperature and baking time, there are 4 total combinations. Low temperature, short time, high temperature, short time, low temperature, long time, high temperature, long time. Now, you could run 2 different experiments, 1 factor at a time, 1 on oven temperature and 1 on bake time. But there are a few advantages and very important advantages to running a full factorial DOE instead. The first advantage is that it takes less overall testing. Now, this gets into sample size, which is a large topic that I'm not going to dig into right now. But basically, in experimentation, we collect data from the experiment and we do statistical analysis of that data. The analysis needs multiple data points of the same setup, in our example, the same recipe, to make sure your results aren't a fluke, right? And how many times you have to do them varies from experiment to experiment, depending on a handful of details. For example, for the 1 factor at a time approach to the cookie experimentation, let's say you needed to bake 10 batches of cookies in the temperature experiment, to really be able to see which temperature was better, right? So it's not just random noise that's making you think it might be better. Then another 10 batches for the bake time experiment. You'd be baking basically 20 batches of cookies for those 2 experiments, right? But for a DOE, where you've combined the oven temperature and bake time into a single experiment, it might take, say, only 14 batches. Now, I'm making up these numbers, but the DOE would certainly be less than the running 2 different 1 factor at a time experiments. Why? Well, in a DOE, we run the multiple factors, and the factors can effectively share the data. Oven temperature and bake time don't each need their own 10 batches. So again, the first advantage is that DOEs take less testing overall. That is a smaller sample size, if you're going to be testing multiple factors. And by the way, sample size impacts test time, measurement time, material costs, labor costs, storage costs, and a ton more other hidden costs and resource demands, etc. So it's important. The second advantage to running the DOE is that you can tell if the factors interact with each other. Now, 2 factors interact when the impact of 1 factor is affected by the other factor. Now, I'll dig into this a bit because it can be a little confusing. In our cookie experiment, we'd be able to tell if the bake temperature and bake time interact. In other words, is the impact that the temperature has on the cookie impacted by the bake time? In this case, they certainly do. Right? And we can talk this through so you can see why that would be obvious. Say you're baking cookies and you went to check on them and they weren't quite done. And if you were baking at a relatively low temperature, you might leave them in, say, a couple more minutes so they can finish baking. However, if you were baking at a really high temperature, you'd leave them in for a much shorter time. You might not even walk away from the oven for fear you'd burn the cookies, right? That's because the impact that extra bake time has, the extra time you leave it in the oven, the impact that that has on the cookies is affected by the oven temperature, right? So it also works vice versa. So oven temperature and bake time are factors that interact with each other. DOEs can look for interactions. One factor at a time experiments cannot. Why is testing for interactions important? Well, there are a number of reasons. But the main one is that it allows you to find the best settings, and here's the kicker, even if those settings aren't the ones we tested in the experiment. Right? For example, we could predict what we want to set the oven temperature and bake time at to get the best cookies. Again, even if we didn't test that exact temperature and that time in the experiment. Now, not only can one factor at a time experiments not do that, they might not even test the best combination of settings from the settings they are testing. And that's because they don't actually test all of those combinations, right? So they can't get that, let alone the ones that they're not testing. How might that happen? Well, say we run an experiment on oven temperature and we found that the higher temperature was better, right? We're doing this one factor at a time thing. Higher temperature better. So then with that oven temperature set at high, we run the bake time experiment and find that a shorter bake time is better. So overall, our conclusion would be the best combination is the higher temperature and the shorter bake time. But it's possible the lower temperature and longer bake time, the inverse, might be better, right? Our one factor at a time experiments would completely miss that. The DOE would not. It would catch it. Now you may be thinking, couldn't I just run a third experiment testing the bake time at the lower temperature? Well, yes, you could. But you'd effectively be running the same thing as the DOE, only being much less efficient about it and taking even more experimental risk. And the third advantage to DOEs has to do with the experimental risk I just mentioned. Notice I said adding the third experiment would add even more experimental risk. You see, there's already more experimental risk on the two separate experiments, the oven temperature experiment and the bake time experiment, than on the DOE. That's because lots of things can change over time that impact the results. For example, if the humidity impacts the cookies and it starts raining during your experiments, adding more humidity, running the multiple experiments can account for that, right? It could cause you to draw the wrong conclusions, right? As you run the series, one experiment might have a lot more humidity than the other. It might feel like it's that factor that you change across those experiments, but you wouldn't really know. The DOE, however, can account for it. First, because since the factors are part of the same experiment, the weather and other things are less likely to change over that shorter time frame. Second, the statistical analysis in a DOE can check for the impact of outside influences over the course of the experiment. Actually, it has multiple ways of doing it. Alrighty, that's the most basic form of DOE and its advantages over one factor at a time experiments. And those advantages grow as more and more factors are introduced. For example, if we wanted to add, say, the amount of sugar as a factor, the advantages would get even larger for the DOE over one factor at a time testing. Further, that's just the tip of the iceberg. Experimental design goes way beyond that. DOEs can be even more efficient and garnish even more information. It's really just a wonderful world of experimental awesomeness. But that is enough for now. Thanks for watching.